I deliberately didn't turn them on. Alright, let's have a look at this. Alright, question number 3a says, find the value of x for which the matrix P is a singular matrix. Now, a singular matrix is a matrix in which the determinant is equal to 0. A singular matrix is a matrix in which the determinant is equal to 0. So P is the matrix 3x, 4, 6x, x. Alright? So let's find the determinant of P. The determinant of P is this times this. So you multiply these two. So it's 3x times x minus this times this. 4 times 6x. 3x times x is 3x squared minus 4 times 6 is 24x. Now we're asked to find the value of x for which the matrix P is singular. Now if the matrix P is singular, its determinant will be equal to 0. So therefore, if P is singular, the determinant of P would be equal to 0. But the determinant of P is 3x squared minus 24x is equal to 0. So right now we're no longer in matrices, we're actually in algebra. Let us solve this simple quadratic equation. I'm going to solve it using the method of factorization. What is common here and here? What can go into which number? What is the highest number that can go into 3 and 24 without even a remainder? So I'm going to have 3x. What is 3x into 3x squared? What is 3x into 24x? 8. And this is equal to 0. So now I'm multiplying two numbers and I'm getting 0. If you're multiplying two numbers and you're getting 0, it is either the first number is equal to 0 or the second number is equal to 0. So therefore, it is 3x that is equal to 0 or x minus 8 that is equal to 0. Divide both sides by 3. X is equal to 0 or x is equal to negative 8 goes over and become what? Or x is equal to 8. Ladies and gentlemen, x is equal to 0 and x is equal to 8 are the values of x for which the matrix P is singular. Alright? B says M is the matrix 3, 2, 4, 1. We're asked to first find the determinant of M. So now we're at B. And B says M is the matrix, and we have what? 3, 2, 4, 1. Now, and we're asked to find the determinant of M. The determinant of M would be this multiplied by this minus this times this. So the determinant of M would be 3 times 1, 3 times 1, minus 4 times 2. So the determinant of M would be 3 minus 8. The determinant of M would be minus 5. The determinant of M is minus 5. So that is I. I is asking us to find M inverse. So I. M inverse is equal to 1 over the determinant of M times adjoint M. M inverse is equal to 1 over the determinant of M times adjoint M. So M inverse would be 1 over minus 5 times adjoint M. Now, this is the adjoint M. Adjoint M would be, you're going to switch these two around. So these two are going to change positions. So this is 1 and this is 3. These two stay where they are, but their signs change. So this is minus 4, minus 2. Again, adjoint M will be, you're going to switch these two around. These two stay where they are, but their signs change. Positive change to negative, and negative change to positive. Ladies and gentlemen, this becomes a negative. This becomes minus 1 over 5, 1 minus 2, minus 4 over 3. So here I multiply a matrix by a number. Fraction is a number, you all know that, right? So multiply the matrix by a number. If you're multiplying a matrix by a number, you multiply all elements in the matrix by that number. So let's multiply. A negative times a positive is a what? A negative times a positive is a what? Negative. 1/5 times 1 is 1/5. A negative times a negative is a what? 1/5 times 4, 1/5 times 4. 1 times 4 is 4, 5 times 1 is 5. So it's 4/5. So this is 4/5. A negative times a negative is a what? Positive. 1/5 times 2 is 2/5. A negative times a positive is a what? Negative. 1/5 times 3 is 3/5. Ladies and gentlemen, this is M inverse. This is M inverse. Alright, now we're at C. Alright, C is, I wouldn't say the question is difficult, but it is a little unusual. Alright, normally this early I don't normally give this question, but it's on the board already, so let's just do it. Alright, we're told hence calculate the values of x and y which satisfy the simultaneous equation. The simultaneous equations and this. So these are simultaneous equations. This is equation 1 and this is equation 2. What we want is we want the value of x that is going to satisfy this. But here's the issue. The issue is this word here, hence. Because hence is suggesting, or hence is saying, whatever I did before must be used in what I'm going to do next. Whatever I did before, what did I just do? I just found what the inverse of m. Whatever I did before must be used in the solution of this equation. So let us show you how it's going to happen. First of all, I'm going to change this up a little. The negative 5 will go over and become positive, and the negative 10 going to go over and become positive as well. So now I'm going to have 1.5x plus 2y is equal to 5. 4x plus 2y is equal to 10. Alright, I cannot forget the word hence. So hence means I'm going to have to use this somehow in answering that question. Now, what I'm going to do is I want to get the coefficients, which is 1.5, 2, 4, and 2 to look like this. Here I have 3, 4. I need 3 here, and I need 4 here. What can I do to this equation so that I get 3 here and 4 here? I'm going to multiply equation 1 by 2. Multiply this by 2, you get 3x. 2 2's is what? 4y. You have to do it to the entire equation. 2 5's is what? So this is 10. So this is equation 1 times 2. Alright? Now here I have 2 and I have 1. Why am I doing this? Because the examiner said hence. Hence mean whatever I just did must be used in what I'm going to do next. Fine. So I need to get the coefficients of x and y in the two equations to resemble m. What can I do to this equation here so that this becomes 2 and this becomes 1? Let's divide that entire equation by 2. So now, divide this by 2, you get what? 2x plus y. Divide this by 2, you get what? 5. So this is equation 2 divided by 2. So now, the coefficients here look like what? The values of n. We're good so far? Alright. Now, I need to solve this using a matrix approach. Now, to solve this using a matrix approach, the first thing I'm going to do is to represent the simultaneous equation as a matrix equation. So to do that, I need the coefficients. This is called coefficient. This is 3, this is 2, 4, 1. So this matrix, all I did to make up this matrix, I simply took the coefficients of x and y to make up this matrix. 3, 2, 4, and 1. Multiply by x, y is equal to, over here we have 10 and we have 5. All I simply did was represent the simultaneous equation as a matrix equation. Ladies and gentlemen, how do we solve a matrix equation of this form? To solve, so first of all, this is in the form m, this is m times x is equal to, let's call over here b. So this matrix equation is in that format. This is m, this is x, and this is what b. The elements of x are unknown. The elements of x are unknown. How do I solve a matrix equation of this form? To solve a matrix equation of this form, I'm going to write back x and multiply over here by m inverse. So this is m inverse b. So here's where, if you did not watch the video on matrices, you have a clue what I'm talking about, and you need to go back and watch the videos. But let's hope you get it over time. So to solve a matrix equation of this form, I must write back m and multiply over here by m inverse. So let's do that. Let's write back x, x. X is what? X, y. And that will be equal to, over here, I'm going to multiply over here by n inverse. Here is where the n's comes in. Remember I said what? N's, don't it? Here is where the n's comes in, because now I'm going to use this in order to solve that. This is m inverse. It is minus 1 over 5, 1 minus 2, minus 4, 3. And I'm multiplying this by 10, 5. Alright, so I'm multiplying what? 2 matrices, and I'm also multiplying whatever I get, I'm going to multiply by the fraction. I'm going to multiply the 2 matrices first. Remember, how do we multiply 2 matrices? We multiply a row by a column. So over here we have 2 rows, but over here we only have 1 column. So let's leave the fraction, minus 1/5. Let's multiply. First element in the row, first element in the column, first element in the second element in the row, second element in the column. What is 1 times 10? Minus 4 times 5. So that's what? The top row by the 1 column. Now I'm going to multiply the bottom row by the same column. What is minus 2 times 10? What is 3 times 5? So now I have minus 1/5. Up here we have minus 10. Down here we have minus 5. Alright? So now the last thing I'm going to do, I'm going to multiply each element in this matrix by minus 1/5. A negative times a negative is a? What is 1/5 times 10? Multiplying by 1/5 is the same as dividing by 2. Multiplying by 1/5 is the same as dividing by 2. So this is a negative times a negative is a what? 10 divided by 5. A negative times a negative is a 5 divided by 5. So the matrix xy is equal to the matrix 2, 1. Ladies and gentlemen, if 2 matrices are equal, they must be of the same order and corresponding elements must be equal. Therefore, x is equal to 2 and y is equal to 1. X is equal to 2 and y is equal to 1. Alright? So we're going to give you another question like that. Write this off. Same thing. Alright, in question 5, we're told that C is a singular matrix. And remember we said that a singular matrix is a matrix in which the determinant is equal to 0. So, since it says C is a singular matrix, let's find the determinant of C. So C is the matrix 6, 5, 2, P. We're told that C is singular. So let's find the determinant of C. The determinant of C would be this times this. So it's 6 times P minus this times this, 2 times 5. Now because C is singular, the determinant, which is 6P minus 10, would be equal to 0. Because C is singular, the determinant, which is 6P minus 10, would be equal to 0. So let's solve that simple equation for P. Therefore, 6P is equal to negative 10 goes over and become. Then I'm going to divide both sides by 6. So P is equal to 10 over 6. Let's simplify. 2 into this is 3. 2 into this is 5. P is equal to 5 over 3. So for P to be singular, for C to be singular, P has to be equal to 5 over 3. B part of the question. It says, given that we have, so this is BI, 3x plus 5y is equal to 19, and we have 2x plus 4y is equal to 14. We are to express the pair of equations in the form ax is equal to b. So let's do this. Ax is equal to b. Now, where ax and b are matrices. Well, the very first thing we have to do is to what? We are being told to represent the simultaneous equation as a matrix equation. It's not difficult to do. I'm going to take the coefficients of x and y. The coefficients would be 3, 2, 5, 4. Multiplied by x, y, and that is equal to 19, 14. Alright? Now, then we're asked now, so this is in the form ax is equal to b. So a corresponds to this, don't it? The next thing we're asked to do is to find the inverse of a. So, double I, a, which is 3, 2, 5, 4. We're asked to find a inverse. Ladies and gentlemen, a inverse is equal to 1 over the determinant of a times adjoint a. A inverse is equal to 1 over the determinant of a times adjoint a. Let's find the determinant of a. The determinant of a would be 3 times 4, so that's 3 times 4, that's diagonally, minus 5 times 2. This is 12 minus 10, the determinant is 2. Let's find A inverse. So A inverse would be 1 over the determinant, which is 2, times adjoint A. Adjoint A is very simple. These two are going to interchange. So 4 goes here, 3 goes here. These two stay where they are, but their signs change. So this is going to be minus 5 and minus 2. So A inverse is 1 over the determinant of A times adjoint A. Adjoint A, these two change positions. These two stay where they are, but their signs change. Now let's multiply everything here by a half. So tell me, what is a half of 4? What is a half times 4? 2. A positive times a negative is a what?
Negative.
This is minus 5 over 2. Multiplied by a half is the same as divided by 2. A positive times a negative is a what?
Negative.
What is a half of 2?
1.
A half times 3 is 3 over 2. Ladies and gentlemen, this is A inverse. The last thing we're asked to do is I evaluate A inverse B. The last thing we're asked to do is to evaluate I A inverse B. Now, A inverse B. If I'm going to use A inverse, I wouldn't use this version of it. I would use this version. Alright? Because I would just easily multiply the two matrices and then multiply by the fraction. So A inverse is a half. And we have 4 minus 5 minus 2, 3. That's A inverse times B. Remember? B is what? 19, 14. So this is times. You might need to get a calculator to help with this. So it's a half. Now let's multiply the two matrices. A row by a column. Alright. First element in the row times the first element in the column. Second element in the row times the second element in the column. Alright, what is 4 times 19? What is 4 times 19?
76.
This is 76. What is minus 5 times 14? What is minus 5 times 14?
70.
So this is minus 70. Then, let's multiply the same column by the bottom matrix. Minus 2 times 19. 3 times 14.
42.
Let's simplify. A half. Well, 76 minus 70 is 6. What is this here? 4? So this is 4. A half of 6 is 3. And a half of 4 is 2. So A inverse times B, A inverse times B is 3, 2.
And what topic is this? Not your topic.
All right, that's the end of the question.
Class.